Welcome to This Explainer. Today, we're diving headfirst into the terrifying and honestly incredibly fascinating physics of what would happen if the Earth suddenly stopped spinning. Just imagine waking up to a completely silent horizon. The sun is completely frozen in the sky, the wind has just vanished, and the world simply stands still. But as we're about to see, that stillness is an absolute illusion, masking an immediate and catastrophic planetary disaster.
So let's kick things off with the ultimate high-stakes question: what actually happens when 1,000 miles per hour suddenly drops to zero? For this scenario, we're assuming the Earth keeps orbiting the Sun exactly like it does right now, but its rotation on its axis just completely halts in a single instant. It sounds like a simple premise, right? But the physical reality of that sudden stop unleashes a chain reaction of truly epic proportions. To really grasp the massive scale of this, we have to look at our current reality. Right now, as you're sitting there watching this, the Earth at the equator is rotating at roughly 1,000 miles per hour. That spin acts as the invisible baseline for our entire existence. It governs our weather, our ocean currents, our day and night cycles. To put that into perspective, 1,000 miles per hour is about 1.3 times the speed of sound. You're literally breaking the sound barrier just sitting in your chair right now. But you don't feel a thing, because absolutely everything around us, the air, the buildings, the oceans, is moving at that exact same speed.
Part 1. The sudden stop. The first terrifying minute.
Listen, this disaster wouldn't be some slow, cinematic wind-down. The destruction would be instantaneous and completely global. And that very first second, the sound alone would be deafening. It would be this cataclysmic roar of snapping bedrock and tearing steel as the planet's momentum violently clashes with its new stillness. By the time we hit 30 seconds, massive horizontal shear force would have already started tearing the surface world apart. And by the end of the first minute, the geography of the Earth as we know it is fundamentally changed.
The real killer in this sudden stop comes down to one fundamental law of physics: inertia. Inertia is just the property of matter by which it continues in its existing state of rest or uniform motion in a straight line unless an external force acts on it. Simply put, objects in motion desperately want to stay in motion. So, when the Earth's rotation suddenly halts, the solid bedrock stops, but absolutely everything else is still bound by inertia.
Because while that solid ground halts, everything not firmly locked deep into the bedrock, people, oceans, loose soil, vehicles, keeps moving horizontally at 1,000 miles per hour. If you're anywhere near the equator, your body would suddenly be launched eastward at supersonic speeds. Entire cities would be sheared right off their foundations in a blink. And it's not just objects on the ground. The atmosphere itself would keep moving, tearing across the landscape as a supersonic weapon, literally flattening whatever managed to stay anchored.
It would literally be like driving down the highway at breakneck speed and violently slamming on the brakes without wearing a seatbelt. Except, in this case, the car is an entire planet and the passengers are, well, absolutely everything on the surface. The immediate global destruction in these first few moments would be way beyond anything we could ever measure.
Moving on to Part 2, Hours of Chaos, the Global Cascade.
As the dust from the first minute settles, and that's assuming there's any dust left, the terror of the first day is only just beginning. Surviving the initial jolt means realizing the destruction wasn't just a momentary earthquake. Over the next 24 hours, the massive momentum of the Earth's systems continues to play out. The oceans and the skies, no longer contained by a steady spin, are now coming for whatever is left.
The sheer chaos occurring simultaneously across the globe is staggering. The oceans, maintaining all that eastward momentum, would surge onto land, creating mega tsunamis miles high that sweep across entire continents. The atmosphere keeps generating supersonic winds, scouring the surface clean of debris. Meanwhile, up in space, our geostationary satellites, which rely on Earth's rotation to stay in perfect sync over one spot, suddenly lose their anchor. GPS, communications, the internet severed instantly. Satellites would actually start falling from orbit, leaving any survivors in complete darkness just as those mega tsunamis hit.
And the biological impact? Just as devastating. Ecosystems are instantly thrown into total disarray. Even if an animal somehow survived that initial blast of inertia, they'd face massive confusion and panic. Think about migratory birds, or insects, or deep sea life that rely entirely on the Earth's magnetic field and steady rotation to navigate. Millions of years of finely tuned evolution basically scrambled in a single afternoon. Almost instantly, the biological cues that govern nearly all life on Earth, our normal day and night rhythms, face a total collapse.
Which brings us to Part 3, Days Without a Sun, a New Orbit.
Moving past the physical destruction, we enter the incredibly eerie reality of the first week on a stationary globe. The dust might be settling, but the sky is fundamentally wrong. Over the next few days, the loss of Earth's rotation completely severs our relationship with the sun. The psychological toll of this would be immense. The daily sunrise and sunset that have governed civilization, agriculture, and human instinct since the dawn of time, they simply cease to happen. The sun stops moving across the sky, forcing this profound, terrifying paradigm shift for any remaining survivors.
Because the Earth is still orbiting the sun, but no longer spinning on its own axis, we hit a bizarre paradox. A day and a year suddenly become the exact same measurement of time. Under normal conditions, a 24-hour cycle gives us day and night. But on a stationary Earth, any given spot on the globe is going to face the sun continuously for 6 solid months, and then slowly rotate to face the cold, dark void of deep space for the remaining 6 months.
This creates a brutal new climate reality. The sun-facing side relentlessly burns, boiling away any remaining surface water and baking the Earth into a barren desert. Meanwhile, the dark side plunges into a deep, perpetual freeze, locked in solid ice. The only potentially habitable zone on the entire planet would be this narrow twilight strip of land directly on the border between the scorching day and the freezing night. Life in this twilight zone would be a grim struggle of perpetual dusk, fighting against fierce temperature gradients that cause endless howling storms.
Finally, Part 4, A New World Order, The Deep Future.
As weeks turn into years and years into decades, the very geography of Earth transforms. The map as we know it is completely erased. And not just by the supersonic winds and the massive waves of the early days, but by gravity itself slowly and methodically reshaping the planet.
You see, the Earth isn't perfectly round. It's a bit chubby. It bulges at the equator because of the centrifugal force of its spin. That spin is currently holding miles of ocean water around the planet's midsection. Without the spin creating that bulge, gravity shifts drastically. The oceans begin draining away from the equator, flowing steadily and inevitably toward the north and south poles. As the water retreats, a massive new equatorial supercontinent slowly emerges from the depths of what used to be the ocean floor.
The math leaves us with a completely unrecognizable planet. We'd be left with roughly 33% northern polar ocean, 33% southern polar ocean, and a massive 34% solid ring of land, an equatorial supercontinent, dividing the two. The globe would literally look like a giant belt buckle, with dry, towering land masses at the equator right where the deepest oceans used to be.
Any surviving human civilization would have to completely adapt to this alien geography and extreme climate just to exist. We'd be clinging to those narrow twilight zones, navigating entirely new gravity, exploring unfamiliar oceans, and facing the grim reality that our dynamic, spinning blue marble has become a stagnant, split world. It truly reshapes everything we thought we knew about our home.
It really makes you appreciate this invisible 1,000-mile-per-hour ride we're all currently sharing, doesn't it? Every gentle breeze, every sunrise, and the very ground beneath our feet rely on a delicate spinning momentum. So the next time you look out at a quiet horizon, ask yourself just how much chaos is actually required to keep our world so perfectly still. Thanks for joining us for this explainer, and we'll catch you next time.